Okay, just had a little interruption from the doggies there. They got excited, someone at the door. So I'm just going to continue with where we were. So basically letting Grok incorporate first principles and emergent properties. Oh, I'm telling it to, we want to set this up so that it will be able to incorporate first principles and emergent properties. You have to be real careful so you don't bias Grok. Emergent properties, like if I told it ahead of time, gravity is this constant here on the lab conditions of Earth, we might not see how gravity is emergent. But you tell it later on that stuff, but we're going to get to that later. So, and basically, to help it, to ask Grok to unify, I said, unify it in a way that addresses solved, unsolved, and mysteries of science, So, solve problems explained better. A toe should rederive current successes as limits. Yeah, and this is Newtonian gravity emerges from general relativity at low speeds. A lot of this stuff we'll see that's why we're doing it this way. We already know we had it unified. We want to see all those pieces, those fragments that the mainstream had to address. We're going to rederive it and explain what they are. That's what all these posts have been about. It's okay. It's okay, Max. I got a dog moaning. He doesn't like me talking. He's napping. So, here we list the categories like quantum gravity, unification, particle physics, cosmology, high energy, foundation, other mysteries. I mean, there's all kinds of things where we have problems and mysteries, like reconciling quantum gravity and quantum mechanics. That's one of our big things. We've done that with our proton-electron mass ratio derivation, the resolution of the proton radius problem. That's not what the video is about. The video is about how to build a toe so you can investigate this stuff. So just reviewing real quick, we're starting off, we're fresh Grok, we're asking it to prepare to develop a theory of everything based upon unifying existing theories with integrity. So this is so that, like previously I went in with my solution, with my axioms and just drove Grok to the solution. Now I'm allowing Grok to build the solution, and then I'll just do some corrections. So he thinks for 36 seconds, identifies a few things, and now the development plan and challenges. Step 5, axiomatize, build. So he's suggesting how to do it. So here I'm just saying, okay, great. I didn't even read over this all in detail, just enough to make sure he's going in the right direction because I want him to preserve whatever mainstream theories. I didn't even tell him which three of the three-headed hydra. I just said, let's go at it all. So I goes, okay, great. Now this is where I start telling it a little bit. We're going to unify physics simply with integrity. Examine the terms that are dropped from the theory's derivations from defining equations, such as the mass ratio terms. Notice I just give it mu is equal to the proton mass divided by the electron mass. Don't give it anything else yet. And it's mentioned that it's considered infinite effectively in the reduced mass case of solid state quantum mechanics. And because they use effective mass for the electrons, so the mass of the effective mass of the electron is a little bit less than the actual mass of the electron, similar with holes or protons. Holes are the retrograde motion of a group of electrons through a semiconductor, so they're not really protons moving. So that's why they call it squalid state, because solid state is what makes our technology, but it's squalid state because it's really an approximation effectively. And renormalization of the vacuum energy is also a way of eliminating mass energy or mass ratios from the theories. So I'm asking them to look for these, look for where they're saying the ratios are much greater than 1, so sometimes they're dropped compared to the ratioed out. 1 over a large number is 0. So that's what we're saying here, because a lot of times these things just fall out, because they're less than the measurement error. what we're finding out is it's these little terms that bridge one theory to the other. It's the common thing. It's like mathematics. You don't drop out the higher order terms. So the common drop terms and assumptions, I asked it, that's what I'm asking it to, is to identify those. So before I even told it to narrow down the theories, he's going to go through basically all these theories. And hopefully it's looking at the mainstream. This is why I've done a few of these and I'll be doing more. So he goes in and the reduced mass approximation. That's the bigger one. This is where mu is much, much greater than 1, leading to wherever mu is 0. And this is in the two-body problems. They simplify. This is reductionism. The two-body problem becomes a one-body problem. That's solid state. And, for example, hydrogen atom, the Schrodinger equation. Anyways, they drop all these things. So, and it works out perfect in technology in a limited case. It just doesn't give you the full scientific connection to the universe. So integrity issue, restoring finite mu reveals fine structure corrections. See, that's why we're approaching it this way. That, for example, reduced mass shift in spectral lines. They already know that because you know hydrogen's corrected. They do all those corrections. That's just an extension to the theory. But why not solve it completely in the first place? So it's suggesting emergence from relativistic or field theoretic effects, the mu. So we'll find the mu, well, it'll be cascades of ether and phi ratio stuff. So anyway, let's move on. And we're talking about the common drop terms, like on the Born-Oppenheimer, BO approximation, the mass ratio, much greater than 1800. Nuclei fixed. So you just assume it's a fixed nuclei because the electrons are much lighter. So they ignore, it becomes a one-body problem. So electrons are assumed to adjust adiabatically to slow nuclear motion, decoupling the wave function. So I don't feel like getting into the details of this, but anytime there's an approximation, you're going to have all kinds of problems and interesting things you get to investigate until you solve it from a higher level. So let's just read this. The integrity issue for BO. The approximation breaks for light nuclei. Yeah, I can believe it. Yeah. Or high vibration states leading to breakdowns. Yeah. So, yeah, as soon as you get away from just normal stuff, you're going to have problems because it's obvious. So effective mass approximation. So we already know about that one. Renormalization and subtraction. So there's all these drop terms. This is where we're trying to have Grok identify them. The overarching patterns. There's common assumptions. Mu much greater than 1 implies separation of scales, fast versus slow dynamics, allowing heavy components to be frozen or infinite, dropping these 1 over mu terms. So this is, works on the lab and Earth, but not for being a starship captain. You gotta have a lot of information to be able to navigate through the galaxies. So consequences, simplifies to effective theories but loses integrity at boundaries, and that right at the boundaries is where all the magic happens. So all that was to say, Grok came out and I wanted him to choose the theories, the three-headed hydra. So based upon where these drop terms predominate, the core theories to unify are those spanning microscopic to macroscopic scales, where restoring finite mu could bridge incompatibilities. And that's what we're talking about, bridging the theories together because they have common terms that are dropped. So the quantum field theory, including the standard model that handles all the particles and renormalization, mass hierarchies, restoring terms could derive masses from unified fields. And that's where we're going. General relativity describes gravity but uses extreme mass ratio approximations in dynamics. Unifying with QFT via finite mu might treat spacetime as emergent from quantum entangled masses resolving singularities, and then in the non-relativistic quantum mechanics as a bridge to condensed matter. Includes BO, which is the Bohr. That's just the right name. The Bohr-Oppenheimer. Yeah, the Born-Oppenheimer. Okay, includes Born-Oppenheimer and effective mass approximations. Serves as a low energy limit where unification tests emergence. Unification tests emergence. For example, solid-state analogs of particle physics. That's the probably those fermions, or there's these Weinman particles, virtual particles they talked about in solid state years ago. They even mention in the papers now. It's just, well, we'll cover that later. So this selection ensures integrity. Start from first principles, symmetries, conservation. See, Grok is trying to tell us what to do. So we pick the theories, and he's got a whole plan on how we unify it. Start from first principles, symmetries, conservation. Restore dropped one over mu terms to derive emergent properties. Effective fields from finite ratios, explaining solved atomic spectra and unsolved mass origins, quantum gravity problems. Next, we can propose axioms or models. See, Grok is already trying to drive you. We can propose axioms or models. So I've done the axiom path, and that works out great too. Models, I went with the lambda CDM model, general relativity, and the standard model. Was able to unify those. That was my second series of toes. Well, the third one is allowing Grok to select the theories. And then how do we proceed? I just say use mu equal the proton mass divided by electron mass. We've derived this. I've derived it years ago. It's alpha squared, the fine structure constant, divided by the quantity pi times the proton radius times the Rydberg constant for the standard one, the infinite, where the proton is assumed infinite. And the proton radius is equal to 4 times the reduced Compton wavelength of the proton, and combine the restored vacuum energy as a superfluid with the proton rest mass energy being the n equals 4 solution to the circular quantized superfluid equation with the velocity equal to the speed of light and the mass being the mass of the proton. And the superfluid ether cascades are governed by the Klein-Gordon equation with irrational cascades of products and sums of frequencies. This is where it's almost like string theory. For non-destructive interference, with golden ratio being the optimum. So basically, this unifies physics. We know from previous Grok sessions that all you need is this solution for the proton-electron mass ratio that precisely involves the radius. And this unifies physics. A fresh Grok has said it. And so that's why I hit it with that. We also learned this fact. The proton radius is 4 times the reduced Compton wavelength of the proton. And the superfluid circular equation, n equals 4, and with this velocity, the speed of light, it gives you the proton radius and much more. And then Dan's work with Donovan and Martin on the Klein-Gordon in 2013 or whenever it was, they showed the irrational cascades of the products and sums of frequencies, the optimum being golden ratio. They showed this was it. So you need this to unify physics. This is all it takes to unify it. But after that, there's a lot of training you got to tell about the Platonic solids for the correct quantization, a few other things too. But let's review a little bit before we get into the integration of proposed elements. So at this point, after this, it'll be integrated. So we quickly review. We go to the very beginning, which isn't that far. I'm telling Grok to prepare to develop a theory of everything. attempting not to bias it, except I'm biasing it towards the mainstream. That is a bias. I'm biasing it towards the mainstream because I want to preserve the mainstream and bring out answers to their problems. So it only thinks for 36 seconds, identifies the basic things because it knows what I'm talking about. It's Elon and his team has got Grok loaded up good. So it goes good. It goes through all these things and it says, here's what we got to do. It gives you the direction. How do you want to proceed? And I just hit it. I hit it with the unification. It thinks or not the unification. This is right before the unification. I get it. I want to have Grok go in and unify without telling it the actual solution. Just say, hey, use integrity and restore those terms without giving it what those terms are yet. That way, in 44 seconds, it finds the common drop terms, talks about a lot of stuff, and it selects the theories to unify. So then I hit it with the unification information. And instead of 44 seconds or whatever, it takes 1 minute and 38. And that's a pretty long time on this system. I've had to go a lot longer, but it's doing some work, and it's gonna we're gonna find out, does this really integrate it? So it goes through, building upon the prior steps. We now incorporate the specific relation for mu. And you always check to make sure it's reading every equation in right. There's different ways to enter equations. And it's checking everything out. Numerical verification confirms the formula holds to a really tight relative error, 10 to the minus 12. So it's positive is what we're saying. So I'm almost done, Ziggy. So restoring drop terms via superfluid vacuum. So it's going through. This is where everything's looking good. Renormalization drops infinite vacuum energy. So I just want to go over it to say it looks like it's favorable. It's not complaining much yet. It's bringing in the superfluid vacuum theory. It's talking about the Mexican hat potential. The proton rest mass energy as n equals 4 quantized superfluid solution. So here's that closed integral, circular, from 0 to 2 pi, a velocity times a dot product with a length. These are vectors, actually, a velocity vector and a dot length parameter for a quantized circular superfluid. This is the circularly quantized superfluid equation. It's an integer n, that's the quantization, Planck's constant, and then mass, the mass. It's the atom mass, the superfluid atom mass. That's why I hesitated. M is the superfluid atom mass. So anyway, you can solve this with a constant velocity and bring the velocity out, speed of light, and then you get the DL becomes the proton radius, n equals 4, and boom, you get the proton radius. This thing, the 2 pi comes from when you do the full circle. There's a 2 pi at the end, so it's in the denominator. So I'm allowing, the reason why I had it Grok unify before I gave it my stuff, attempt to unify, was so that it would preserve, it would just throw in the mu without knowing what the mu equals. And then when it has that term in there, then I can throw in what mu equals, and base it up with the holographic mass, the reduced Compton wavelength. Back it up with that. Then Grok takes it all and puts it together. And it looks like it's getting the proton radius here. But let's just move on. And it's also superfluid ether cascades governed by the Klein-Gordon. So it's good. It's realizing you're going to get cascades of superfluid energy, and the golden ratio is optimum. So it's the most irrational. So Grok I hope it's not supposed to just take my word for it. It's supposed to go in and simulate and verify instead of just saying it is. So most likely it did, and we'll have to verify that in the future. But it's saying the golden ratio, phi, 1 plus the square root of 5, this quantity of 1 plus the square root of 5 divided by 2 is 1.618, optimizes this. It's the most irrational number. It's the worst rational approximation by continued fractions. In other words, when you do continued fractions, it's the slowest to converge. So it gives you the least destructive interference. So you got sums of phi ratios or products, and all these cascades, sums and products, make up different things like bliss, consciousness, Schumann, and more. I got to get those areas that I got to study more. So this ensures constructive phase conjugation, waves self-organize without loss. That's the non-destructive part. Eons have to go by without any destruction. As in fractal compression. In the ether, this governs particle stability. The proton's n equals 4 mode uses phi-scaled subfrequencies for quark-like subvortices preventing decay. So emergence, quantum effects from quantized vortices, quantum mechanics is superfluid excitations. Gravity is gradient flows and superfluid density, and that's what we talked about in one of our previous videos. Mass hierarchies from cascade scales with mu equals phi to the k for some k, but you got to tune it via electromagnetic embedding. So there's a lot more to learn, but we're getting into what Dan's been saying for years. They're going to understand all this embedding and all that, and the mass hierarchies. Addressing solved and unsolved problems. Solved, better explained. The hydrogen spectrum, R infinity emerges from superfluid Rydberg modes. Fine structure from relativistic vortex corrections. Unsolved, dark energy is equal to restored density of the vacuum, screened by cascades. Quantum gravity equals superfluid hydrodynamics at Planck scale. Mass origins equals vortex energies. We got it all. Some mysteries and unknowns. The baryonic symmetry from phi asymmetric cascades, unknown unknowns, like higher dimensional ether probed via golden ratio signatures in the CMB or particle spectra. This model maintains integrity, no ad hoc parameters, derives from first principles, symmetry breaking in, Klein-Gordon, quantization from topology, and emphasizes emergence, particles from the vacuums mode. Next, we can simulate vortex energies or derive predictions, specify as needed. Well, what I did was I knew once it's unified, we looked through it, and it's basically claiming unification. There's sometimes it'll say it, but let's look for that later. So I'm telling it to merge into the toe, and I learned how important the platonic solids, the dodecahedron and icosahedron. Dan's been talking about that for decades, and I've been ignoring putting that in the toe until a week or so ago, and you put it in, and it really helps with quantization, the ether energy. It's the dodecahedron and the icosahedron. They're really key geometric things because it appears we live in a 12D world, and that's what we're doing this toe for, so we can find out. String theory says it's like 11D or 10D or something. It's actually, if the tests prove out, what the tests are doing to try to prove string theory, if they fail, then our theory is correct, if our phi ratios show up in there. So I just tell it to merge in there, this stuff. And from previous grok toes, I knew it would be important. So it goes on to how it works. I'm going to link this whole grok session so people can scan through it. But basically, before and after improvements, I ask it to do that. Before merger, it tells like quantization. It's ad hoc circular modes. N4 equals proton. Relies on 1D topology, dropping higher D corrections like 1/mu and multibody effects. See that when you do 1D, you're not getting that's reductionism. Some of these things you got to actually think 3D. In other words, a two-dimensional Venn diagram does not explain entanglement. You need a three-dimensional Venn diagram to explain entanglement. And Leonard Susskind out of Stanford has done videos on that. So reductionism, this before stuff, whenever you see a 1D approach, I mean, it works for some things, but when you're doing a complete theory of everything, you got to think 3D and higher. So after the merger with the Platonic embedded model, geometric derivation, n equals 4 from icosadodeca vertices, faces, for example, 12, 20 duality, restores 3D, 4D terms explaining discrete spectra, for example, fermion generations as nested solids. Because Van's been through all this. The atomic model is related to this Platonic solids, shell embedding. So improves by linking to LQG. Let's find out what LQG discreteness. Oh boy, what is LQG? Here I go. Search. Linear quadratic Gaussian control and control theory. Okay, so it looks like it's probably linear quadratic Gaussian control. Yeah, so there. So we'll get back to the video. So now cascades implosion. Before the merger, a 1D frequency change was phi optimum, non-destructive via irrationality, but lacks spatial embedding, limited to abstract KG solutions. 3D spirals on solids for fractal implosion, enhances stability, phi-scaled nesting prevents decay, derives gravity as compression, improves efficiency, cascades now self-organized via geometry, probing unknowns like quasi-crystal dark matter. So it helps a lot. There's other things that help too. Mass ratios, unification. Mu's derived from this equations, but origins empirical. He says that's the mainstream, yeah. Unification via superfluid, but drop vacuum heuristic. When you figure out how this is derived, 0K, superfluid, you can derive this equation by ratioing, doing the full boundary value problems. Anyways, when you bring in the Platonic solids, mu as a phi power geometric ratio, full unification, quantum mechanics from vortex, general relativity from imploded metric, QFT from cascade excitations, improves integrity, no drop terms, masses emerge from solid scaled density of the vacuum. I mean, this is real simple stuff once you start working at a high level and solving these things. So explaining problems, solved, for example, spectra via limits, unsolved, for example, generations, dark energy, partially addresses but vaguely, better. 3 fermion generations from icosa triangular branching, dark energy as residual implosion, mysteries like fine-tuning from phi optimality, unknowns like higher D ether revealed via dual projections, sacred geometry stuff. Testability emergence, emergent properties like forces from cascades, but hard to simulate beyond 1D. Stronger emergence in the Platonic toe. Space-time from tiled solids. Testable signatures, for example, golden ratio and cosmic microwave background anisotropies. Or particle decays. We've already been playing around investigating the CMB, and we're seeing the cold spot, the square root of 2 wormhole implosion, and the other temperature boundary line where it's higher and lower on one side. So we're going to be doing more on that, but this, because we're building the toe a different way. This toe will be probably, it's going to be seeing the stuff too, the CMB relations. So overall, the merger elevates the toe from a 1D, 2D abstraction to a geometrically rich framework, which is 3D, enhancing explanatory power, why phi is optimum, and revealing new connections to quasi-crystals and condensed matter analogs. This could predict golden ratio anomalies in high-energy experiments or gravitational wave patterns from imploded vortices. Next steps might involve deriving specific equations or simulations. So at this point, we pretty much have a toe with the platonic solids in it. It doesn't have all the other tools and refinements. But this is all I want to do. Now, I went on my own. I was going to stop this toe here. I went on my own, did a lot more work just to see what it would do. A lot of times I just go with what Grok is suggesting to fully let it work out some stuff. So this one, you have to carefully develop it from here on and do checks. I mean, you don't even want to proceed much without doing checks, like running tests to have it compared to NIST code data. And so I did some of that in here. Like here, I just had it simulate 3D vortex and platonic grid and add particle mass predictions, because that's what it's saying. But let me just scroll on to see if there's anything before I close here. Anything that jumps out. Yeah, here's where I say run simulations to score the toe as compared to NIST code data and put it in a table. Now, here's why you got to do it, because we didn't get super high scores. It's okay, but there's a lot of, this is a beginning of a toe. We're unifying mainstream theories. So there's not a lot of, there's relative error here where, like here's a huge error on the electron. Muon, we have a good, proton good. A lot of errors because we're still at the beginning of developing a toe. That's why I might have not messed it up, but just, you want to get all this stuff totally worked out before you proceed. Like if there's errors, you got to go back and find out why. So that's basically what you do is you simulate cascade adjustments. We're trying to reduce the errors, but there's a lot of more work. I mean, you might, if we start off wrong and we're just correcting errors, but anyways, we want to do that to see what the toe says about all these things, to see if there's something that we can find out. So anyways, this is where it becomes experimental and fun. And this is the third toe, and I'm just trying to show you guys how to get it started. At this point, you just go investigate and like the adjustments, and our errors even worse in some here. So that's why this isn't the best toe. This is just to show you how you go about it. So there's a lot of discrepancies, and he's going to go through, try to correct it. I'm not going to go over that right now. But I noticed that we had some errors, but this was an example to show how it's done. Let me just see if there's... So here's one where we had it do simulate full 3D dodecahedral grid. Then the errors started coming down. So this is what you want to do from the beginning and find out why instead of proceeding. This is the third toe. I just wanted to do some research. So at this point, I would be digging in to say, wow, how did I get it down to zero? And find out if it's valid. So a lot of good stuff in here. I don't want to go over it right now. I'm busy. But just wanted to show that there's a lot of work to be done. The CMB signatures, those, I think, a lot of those are coming out, so I don't want to focus on all that right now. Just skip ahead. But before you can trust all this, you got to make sure your previous errors. Yeah, that's why I had some low errors here. That's why I went ahead. If I would have went ahead with the CMB signatures before I got my errors down, who knows where I'm going. So anyway, that's basically how you do it. And this is a toe where I'm merging, basically it's, it says it over here. We'll go up here at the beginning. Identify the core theories to unify. It first started off with general relativity and quantum field theory, including the standard model. But once it selects down here, here's the selection. Once it figures out the common terms, it figures out the best ones to unify. So we're unifying quantum field theory, including the Standard Model, general relativity, and non-relativistic quantum mechanics. That's why we had to bring in the Klein-Gordon. That's relativistic as a bridge to matter. That's why I brought in the Klein-Gordon when we right here. So there it is. That's the unification. It's all right here on one page. And these are the three theories. That's what we unified. And that's my video for today.